Welcome. In this video we're going to provide an introduction to exponents. You covered exponents first in 6th grade, so hopefully you remember a little bit about what an exponent is. Here's the definition. Exponents are a way for us to show repeated multiplication for the same base factor. Let's look at what that means. Our first example, we see 5 raised to the 4th power. 5 with a little 4 above it, and again we pronounce that 5 raised to the 4th power. The 5 is our base factor, or we might call it the base term. The 4, the red number that's small and above and to the right of the base, is called the exponent. That exponent tells us how many copies of the base, 4 of them, we need to multiply together. So here we know 5 to the 4th power really means 4 sets of 5 multiplied together. If we were to do 5 times 5, that's 25. Another 5 times 5 is 25. So we could double check. We could look up here and say 5 to the 4th power. We could say 5 times 5 times 5 times 5, that's 625. We could also see that 25 times 25 is 625. So 5 to the 4th power in exponential form could be written as 5 times 5 times 5 times 5 in expanded form, and that all equals 625. We see that exponents can make a number big very quickly. We should note from now on we don't want to be using calculators as we work through exponents in 8th grade, but if necessary that Google toolbar again can also help you out. Now let's do a few more examples here. If we ever see -8 times -8, 2 copies of -8 multiplied together, we could rewrite that in exponential form as -8 squared, or -8 to the power of 2. We see the power of 2 has a special name, it's called squared, so if you ever hear something squared, they mean raise it to the 2nd power. If I do -8 times -8, we see a negative number times a negative number actually makes a positive 64. The next example, we see 10 raised to the 3rd power. Another way to say the 3rd power is cubed. Think of a cube having 3 dimensions, length, width, and height. 10 cubed really means to do 10 times 10 times 10. If I do 10 times 10, that's 100, times another 10, that's 1,000. As we're going to work on in future weeks, whenever we do 10 raised to an exponent, it just becomes a 1 with that many zeros. 10 to the 3rd is 1,000, or a 1 with 3 zeros at the end. 2 last examples, what if we have decimals or fractions and we're working with exponents? Would follow the same process, we just have to remember how to work with fractions. This number here says 0.5 or 1/2 squared. That means we would have to do 0.5 times 0.5, and 1/2 times 1/2 equals 0.25. Similarly here we see a fraction 1/2 times by itself 3 times, or 3 copies of that half, so we could write that in exponential form as 1/2 raised to the 3rd power. Now if I do 1/2 times 1/2 times 1/2, we know 1 times 1 times 1 is still 1 for the top of the fraction, and 2 to the 3rd power, or 2 times 2 times 2 is 8. So 1/2 times 1/2 times 1/2, or 1/2 cubed, makes 1/8. What do we see with decimals and fractions that are smaller than 1? We see if we raise them to a positive exponent, the answer actually becomes smaller.